Hey, here we are again for Mr. Bresciani's math class. Today we're going to look at 9.2 patterns in a table of values. So we're just going to continue on from where we left off last class, looking at more table of values and graphs. So today we actually have three outcomes, which are all very similar, but I split up into three for you guys. The first one is I can graph points represented by a table of values. The second is I can decide if a table of values represents a linear relation. And three, I can identify relationships on a table of values. So one thing again to remember here is that your linear relations, right here, you know that's linear relation on a graph if one, you have a straight line in your graph. Right away, if it's a straight line, it's linear relation. And if you can see that nice pattern in your table of values. If they're changing equally, you know it's going to be linear relations. So we're going to look at that more later on today. So let's take a look at our first concept. Right now we're just looking at graphing points represented on a table of values. In our last lesson we kind of looked at the opposite. We went from here to input them onto here. Now we're going to do the opposite. So all I want you guys to do for this question is look at your table, and I'd like you to plot these points on your graph and show me if it's a linear relation or not. So what you can do is pause here right away and draw your own, and then hit play when you're ready to see the answer. Okay, so let's take a look at our solution. So first I'm going to do is I'm going to draw on the side here just so you can see my axis. This is my y, here's my x. Now the next thing I've got to make sure I do is just start labeling my either side. So x, I'm going up here by 1, 2, 3, 4. But because I don't want to have it as 1, 2, 3, 4, then I'm only going to be using this part of the graph, I'm going to space out a bit. So every 2, let's say, I'm going to do my values. And there's 5 just for fun. Other side, I look here and I've got to go up to 12 is my highest value. So I can do it a couple ways. I could go up by 2s if I wanted to. I could go up by 1s, whatever I want to do. So I'm going to try just going up by 2s. That's 2, that's 4, 6, 8, 10, 12, and then just 14 for good luck. Now I've got my values there done. The last thing I have to do here is just start plotting them. So when I look here, my first set of points is x0, y0. So when I plot that, this is 0. So there's my first point. I'm just going to draw it in blue. Here's point number 1. My next set of points is x1 and y3. So I look at x1 here and go up, and y3 will be right in between the 4 and the 2. So I'll plot that point there. My next set of points is x2, y6. That's right there. Keep going. My next point is 3, 9. So I go up 3 to about 9. Right there. And my last point is 4, 12. So I go along 4, right up to 12. And when I look at it, I've got a straight line. So right away I know it's a linear graph. But I also know it's linear because when I look over here, my x's go up evenly, or not evenly, I shouldn't say that. I should say consistently by the same number, so it's up by 1 each time. And my y values are consistent as well. They're going up by 3 each time. So you can see your pattern. I would know, even not looking at this, that if 1 is 3 and 2 is 6, well, that 3's got to be 9 and 4 would be 12. I'd know that right away because they've got a nice pattern there. Now, speaking of patterns, let's take a look at our next concept. So now we're looking at a table of values and linear relations. So now rather than just looking at the graph, we're just going to focus on the table itself. So here when we look at this table, my x values are going up by 2, 4, 6, 8. And I've got here the amount changes by this. It's the same change. It's 2. So it changes by the same amount, which is 2. When I look at the other side, it's going 7, 9, 11, 13. It's also changing by 2, but more importantly, it's changing by the same thing. Right there, I actually know this is a linear relation. Because even though I can't tell it's a straight line right away, there's no graph, it's consistent change, right? It's predictable. I can see the pattern. At 2, it's 7, so then 4 is going to go by another 2 and be 9. Then another 2 will be 11, another 2 will be 13. So what I said down here is the pattern is evident. Every y value increases by 2 for each x value. So you can see that's exactly what it is. 2 is 7. My next x value is going up by another 2, by another 2, by another 2. So it's consistently changing. And if I were to plot this on the graph, it would look like a nice straight line. And now we've got our pattern. Let's take a look at our next concept now. And actually, before we get to that, let's try this out. Which table here shows a linear relation? Take a look at it and pause and then play when you're ready to see the solution. Okay, so we're looking at both of these tables. I've got one here, and when I'm trying to figure out which is which, I've got to see if there's a pattern going on. So right now I can't tell if there's a straight line to see if it's a linear relation. So we'll start with this one here first. So when I look at it, my x values here are all going up by 3. That's one pattern, good for the x. Now look at the y. It's a difference between here and here is 4. Here to here is 3. Here to here is 4 again. So right now you can see it's inconsistent, right? I can't say it goes up by 3 every time because it doesn't. It doesn't go up by 4 every time. It's gone here and it changed. So I've got no pattern. I couldn't tell from this here what the next number would be. You could argue and say it's 3, but it could be anything based off of this. So right here I know this is not linear. Why? Well, first the pattern isn't there, but if we were to graph that, we get something like this. Consistent, dropping up and down. See, you'd have a curve. And that wouldn't work because it's not a straight line, so it would not be linear. Let's look at our second one now. Well, this side, 0, 1, 2, 3, 4, it's up by 1. This side, 0 to 3 to 6 to 9, up by 3. So both sides have a pattern that I can predict. So when I were to plot that on a graph, it would actually be a straight line. And then I know I've got a linear equation. So you can just tell by looking at this one. Because 0 to 3 to 6 to 9 is consistent, 1, 2, 3, 4 is consistent, you know it's going to be a linear equation because it's a nice pattern there. Now let's look at our last one. And that just goes back to patterns again. We're going to identify relationships on the table of values. So what I want you to do is look at this table and complete it for me. Because this is going to be a linear relationship. And that's what it is. Knowing that, you know there's going to be patterns. So your job right now is to finish out filling the table of values here using what pattern you see here. So you can pause it here and then hit play when you're ready to watch the rest. Okay, so let's take a look at it. So when I look at x1, y is 3. When x is 2, y is 6. So right here, you can see you've got a pattern. It's going up by 3. For every x value, it's going up by 3. So then the next one, when we look at it, 6 plus 3 is going to be 9. Next value plus 3 is going to be 12. Next value, 15. So right there, we've taken a look at our pattern and filled in the rest of the graph. You could also look at it and say, okay, for x, I can always predict what y is using that. I could tell you right here that when I look at y and x, I could say that y is always 3x, or 3 times x. And what I mean, let's take a look here. We got our y value, which is 3 in the first one here, equals 3 times that first value is 1. 3 equals 3. I've got an equation I can see here now. If I was to try, let's say, the second part, well, if my equation again is y equals 3x, I could tell you what the next y value would be by doing this. Y equals, well, 3. And that next value, if x was 2, y would be 6. If I try it again, if I want to know what y is, I have my new equation, y equals 3x. If x is 5, then y is going to be 15, which you can see there's that. There's that. And this is a bit of a preview for next one. I just wanted to kind of stick it in here quickly so you could see what's coming up. But we're going to look now in our next 9.3 at equations like this. Don't fret if it doesn't make sense right now, but that's just a bit of a preview what's coming later on. Other than that, we're done for today. You can check out the assignment on the page and go from there.